All right. Well, hi everyone. Thank you so much for joining me today on this discussion about Jack Voltaic the Game. Today I'm going to talk a little bit about this project that I've worked on, but more specifically, how you can create games in Unity using GIS. So, you guys are probably wondering, who am I and why am I presenting to your class? So, hi, my name is Emily Nack. I recently graduated from RIT, where I studied game design and development, and I'm currently working at the US Army Cyber Institute at West Point as an infrastructure systems engineer. So, I first started interning there in January as a software engineer, and that's where I was tasked with working on Jack Voltaic the Game. So, what is Jack Voltaic the Game? It is basically a gamified experience in Unity developed by myself and two other interns, and it's designed to educate on critical infrastructure resiliency and to highlight technical and policy interdependencies. And, oop, I see there's a chat. Oh, you guys are probably thinking, whoa, this has nothing to do with my class. But a major goal of the game was actually to incorporate real world data and geographic information systems. So I'm going to talk to you about my experience with that and the tools and software that I used. And I'm also going to talk about what that process looks like to hopefully help you out with some of your work later down the line and to get you excited about the possibilities of GIS and games. So, first, let's talk about the ArcGIS Maps SDK for Unity. Some of you may already know what this is, but in short, it's a Unity plugin that gives access to real world maps and 3D content in ArcGIS. This is what we use to extract and visualize data from ArcGIS map layers in Unity. So, some other key features that I wanted to point out is its ability to create interactive GIS visualizations, which combines GIS data and game environments, the ability to visualize layer attributes, which allows you to apply different shaders to render data based on 3D object scene layer attributes. And one of the most important features, in my opinion, is the ability to geolocate game objects, which essentially means that you can place game objects at specific geographical locations in Unity, which is super neat. So let's dive right in and talk about the process behind it all. I'm going to break things down into three stages. So, first, we're going to need to collect the data. Then, we need to prep the data using analysis and data management tools in ArcGIS. And then, we need to export the data so we can use it in Unity. So, just as a disclaimer, in the next few slides, I'm going to explain what tools I use, their purpose, and where you can find them in ArcGIS, all that good stuff. So either feel free to follow along in ArcGIS if you'd like, but don't feel like you have to. Now, I know this is going to seem like a lot of information at once, so I apologize in advance. But since this is being recorded, I wanted you guys to all have an in depth reference to look back on when you start working on your projects and also when you start diving into the world of GIS and games. So, as I mentioned, data collection is the first step of the process. What's great about ArcGIS is the fact that you can import data in many different forms. So you can import a CSV file, data from a URL, or you can import shape files or other map layers that have collections of geographic data. Now, for Jack Voltaic, I was looking for critical infrastructure data. So it took a lot of research, but I came across HIFLD open data, and that's a national foundation level geospatial data within the public domain. And it can be useful to support things like community preparedness, resiliency, research, and more. Now, what's really neat about this site and a lot of other sites out there is that you could favorite data sites or data sets, which directly imports them into ArcGIS. Now, I'm not sure if you noticed, but in the previous slide, I had another link that linked to ArcGIS Hub, and that has a lot of other open source data that you can use to explore and favorite to your account. And I definitely recommend checking this out when you first start playing around with things. And don't worry, I can send a copy of these slides afterwards to everyone so that way you guys can access all of these links too. So, now that we've located and added our data to ArcGIS, we're going to have to start preparing our data to export. Now, in my opinion, this is the fun part of the process because it's where you can really start building and customizing your data to create the map layers that we're going to use in Unity. So the image on the left is an example of one of the map layers that I created for Jack Voltaic. I know it's definitely not the prettiest, but I'm going to explain later on how I replace these color tiles on the left with game objects in Unity, which you can see in the image on the right. So, being that the data prep stage is specific to how you want to present the data, there's a few steps that I may have taken that may not be relevant to your work. And that's okay. Don't feel like you have to follow everything to the T. I still want to briefly go over those just so you're aware of some of the really cool things that we can do in ArcGIS. So my first example of that is for Jack Voltaic, I added a lot of different types of data to ArcGIS, but they were all in separate layers, which you can see in the image to the left. In this case, I had to perform spatial joins to combine all of the data into one layer. Now, if you want to create custom fields or edit existing ones, you can use the Calculate Field tool to write your own Python expressions. An example of a simple expression that I wrote was to change the field value to true if it contained a string, which I use when creating game objects in Unity based on type. Once again, this is specific to Jack Voltaic, but I definitely strongly encourage you to read the documentation for it, which I have linked in all of the slides. Now, to create that tiled look that you saw here on the left-hand image, I use the Generate Tessellation tool. Now, for Jack Voltaic, we wanted to create like this digital hexagonal game board in Unity. So this tool helped to create a tessellated grid of regular polygon features that covers a given extent. So the tessellation can be made out of triangles, squares, diamonds, hexagons, transverse hexagons. It's a really neat tool, so I definitely recommend checking it out. So now, if you use the Generate Tessellation tool in the previous step, you're going to need to use the Calculate Geometry Attributes tool to specify the latitude and longitude coordinates for each tile. So first, just going to walk through this with you guys. You're going to add two field types or two fields of type string to your map layer. Then you're going to go ahead and navigate to Analysis, Tools, and find the Calculate Geometry Attributes tool to open up the tool panel, which you can see on the bottom left. And then from there, you're going to go ahead and choose your input map layer, those two string fields that we created, and you're going to specify a centroid X or Y as their property. And this is going to populate the empty fields with the centroid X and Y coordinates of each object, which means that we're just assigning a X and Y coordinate for each tile. Now we're going to start getting into those necessary steps in data prep. We're going to need to use the Layer 3D to Feature class tool to export feature layers with 3D display properties to 3D lines or multi-patch features. And just to better explain that, because it's a lot, when we export the layer for ArcGIS Online, it needs to be a 3D layer with multi-patch features, and this tool is going to help us do that. So to open up the tool panel, as I mentioned before, you're going to go to Analysis, Tools, and you're going to type in Layer 3D to Feature class. Then you're going to need to specify an input layer, which is the map layer that you've been working on. The output feature class is going to suggest a file name, which you can change. And then you can disable any symbology that you may have added to the layer by clicking the checkbox for Disable Color and Texture. Now, I'm not sure how familiar you guys are with ArcGIS yet, but you can do really cool things like change the color of the map, you can change the texture. And if you don't want that when you export it, click that checkbox for Disable Color and Texture. Now moving on, we need to use the feature class that we created in the last step to create a scene layer package or .slpk, and that can be exported to ArcGIS Online. Once again, we're going to navigate and find that Create 3D Object Scene Layer tool, and we're going to open up the tool panel, which you'll see on the left. Here, we're going to have to specify that feature class that we created in the last step as input, and then we can name the scene layer package in the output field and specify any output coordinate system if you'd like. Now, usually there's an option for the output coordinate system to keep as the same as your input, and I always do that. But if you want to export it with a different coordinate system, you can do that here. Now, finally, we can use the Share Package tool to export our scene layer package that we created in the last step to ArcGIS Online or ArcGIS Enterprise. So once again, we're going to open up that Share Package tool just like you did with the previous tools. We can set the input package to be the .slpk that you created in the last step. And now one thing that's important that I want to point out is to add a summary and tags. I'm going to show you guys what ArcGIS Online looks like and how you can find the things that we're creating here. But one thing that I regret is not putting in a good summary and tags. I have so many map layers on there, and honestly, I don't know what half of them are because I did not label them correctly. So highly suggest putting in a summary. And then you also want to make sure to check the publish web layer and the share with everybody checkboxes on the bottom of that panel, because this is going to cause issues in Unity later down the line. And I want to make sure I can save you guys some time and some headache. So That's awesome. I know that was really quick, but we've exported our map layer to ArcGIS. But, where exactly does it go? So I'm going to go ahead and show you guys ArcGIS Online and what it looks like once you export these map layers from ArcGIS. Are you guys able to see this ArcGIS Online screen here? Just give me like a thumbs up or something in the chat. Okay, cool. All right, so this is ArcGIS Online. I'm not sure if you guys have played around with this at all yet, but it's super simple. Just use your ArcGIS login, and then you have access to the RIT ArcGIS Online. So now for all of these map layers, we're going to go ahead and go to Content. Once that loads in, these are all of the map layers that I've exported from ArcGIS to ArcGIS Online. Like I mentioned, I have a lot, and this is the part where I sort of regret not adding in a summary and tags. But if you want to see these map layers in ArcGIS Online, you can go ahead and click on them. This is going to load into the screen where you can either open up the map layer that you created in a scene viewer. You can see that description that you added and things like that. But the most important part of this is at the bottom right, you're going to see a URL. And now this is the URL that we're going to use in Unity to import these map layers. So I'm going to hop back over to the presentation. Now that we've exported our scene layer package to ArcGIS Online, as you just saw, we are finally ready to start working in Unity. So for the sake of time, I'm not going to go over how to install Unity and the ArcGIS Maps SDK, but I have provided a link to the installation and setup guide. So there's multiple different ways that we can view data using the SDK. And of course, each has its own pros and cons. So you can either use the Map Creator UI to add layers quickly, and with that, you don't have to write any code. And it's definitely a great option if you're not comfortable with C#, but it does limit you from setting up custom scenes and doing a lot of custom things in Unity. With this option, what you export from ArcGIS is what you're going to see in Unity. And that may be exactly what you want. But for Jack Voltaic, I wanted a lot more customization, which of course requires programming. So if you want to get into the programming side of things, you can use the C# API to access the plugin source code and start creating those custom scenes. So just as an example, I'm going to show you both versions super quickly. This is the Map Creator UI on the left-hand side. Here you can specify the type of scenes. You can choose either a global or a local scene. You can specify the origin coordinates of your map layer. You can specify where you want your camera positioned in the scene, the type of base map to use, and then you can put in that data layer URL from ArcGIS Online that I just showed you. Now, the image on the right is an example of what happens when you run Unity with all that information in there, and this is with a map layer of New York. Now, believe it or not, this block of code also produces the exact same result as using the Web Creator UI. So in code here, we're basically using the C# API to create a new ArcGIS 3D model layer using the URL, and then we're using, then we're adding it to the ArcGIS map. So as I mentioned, if you're more comfortable with programming, you can start to create map layers that use custom game objects. I will admit this process is complex and I can have a whole discussion about it on its own. So if you're interested in learning more about it, please let me know at the end of the presentation or feel free to reach out to me afterwards. But now that you hopefully have a better understanding of how we can create map layers in ArcGIS and visualize them in Unity, I would love to show you a quick demo of Jack Voltaic the Game and showcase how I use GIS to create the game. So I'm going to go ahead and switch my screen share. All right, can you guys see Unity? Cool. All right, so let me go ahead and start up the game. I will admit, if you haven't worked with Unity before, it can be really slow, so just be patient. But when the game first starts up, the player is prompted to choose which state they would like the game to be set in. So that basically is telling Unity which URL to choose from ArcGIS Online. I'm going to go ahead and choose Georgia. So this game is a local multiplayer game. So we have the blue player, which is made up of different organizations, and their goal is to maintain and strengthen their facilities on the map. We also have the red team, which is made up of malicious actors or cyber adversaries, and their goal is to compromise these facilities and to try and go unnoticed with their actions. But for the blue player, I'm going to go ahead and choose the water organization. So right now you're going to see that base layer or base map layer populate in Unity, and then you're going to see all of those game objects on the board. Basically, if you remember a couple slides ago, we had those tiled look from the generate tessellation tool. I am using the coordinates for each of those to populate the map with game objects and their positions. So right now we are looking at the blue player UI. So what are some of the options that we can do? As the blue player, we can go ahead and show some of our facilities on the map. You're going to see all of our water facilities on the map highlight, and they're highlighted in different colors. It can either be yellow, red, or green based off of their flow, which I'll show you over here. Flow is basically how well a facility is doing, and that value is gained based on its internal and external attributes. And now you might see as I hover over some of these facilities, you're going to see some have more information than others. And that can be thought of as feedback, which is basically how much you know about your facility. Now, what if we want to change some of these values to help strengthen our facilities? We can go ahead and go back to player actions, and we have a whole bunch of options. So we can either increase their feedback to know a little bit more about some of those unknown values, or we can go ahead and boost some of the internal and the external values. And that's all based off of the funding that the player has. Now, a big part of critical infrastructure is the fact that everything is interconnected. So, one thing that we wanted to be able to show is we wanted to have the ability to click on different facilities and show what it's connected to. So, for example, if I click on this facility here, these are all the other facilities that are connected. That means that if someone were to target an attack against this facility, these other facilities are also going to be affected. And one of the biggest facilities where that happens is these electricity generation sites. That means that if the flow increases on this facility, all of these other highlighted facilities are also going to be impacted. Now, one other feature that we added in is the ability to toggle map layers based off of type. So if it's a bit too overwhelming to players, you can turn off certain map layers that may not be relevant to you. And you can also do the same thing for flow too. So maybe you only want to see facilities that have flow that's less than 30%. And we can do that. So that's a little bit about some of the actions that the blue player can take. If we go ahead and hit the next turn button, the red player is going to be prompted to step in and play. If we hit continue, you'll see this UI is pretty similar. They just have different actions. So if we take a look at some of the actions they can either select facilities to compromise their internal systems, their external systems, or we can trigger events on certain facilities. So if we go ahead and hit the trigger event button, we can try and trigger a ransomware event to happen here. If we go on to the next turn, the blue player is going to be prompted to step back in. And at the beginning of each turn, there's different events that can occur. Now, these events can occur based off of flow. So that means that if you're not paying close attention and strengthening your facilities and they have a low flow, they have a higher chance of these events occurring at them, and in turn, a higher chance for damage to occur at these facilities. Now, the blue player can either choose to ignore these events, or they can use some of their funds that you see in the bottom right to mitigate these events. But this is just a very brief overview of Jack Voltaic the Game. And yeah, if you guys have any questions about the game or the presentation, now is the time. I'm just going to switch back to this screen here.
Could you talk about how did this happen? How did you go from an IGM student, game design development, to Army Cyber Institute? Wonder if the students Yeah, it's a little bit of a shout out for the path you took, but um, yeah, it might inspire some students to think broadly about what they're doing. Bear in mind,
Sure.
not everybody will be an IDM student here.
Sure, yeah. I mean, I feel like this advice can go for any type of student. Um, the biggest thing that I did was to try out things that I didn't expect I would like. So, for example, I guess 2 years ago at this point, there was a brand new class in IGM. It was a war games class, and I needed an advanced elective, so I decided I would take it. I knew absolutely nothing about war games. I didn't even know that there was such a thing, but I took the class and I ended up loving it. And the professor, he's really great, Professor Abbott. I highly recommend taking the class again if it's still available. He has a lot of great connections, which led me to the Army Cyber Institute. So in January, after taking the War Games class, I was offered an internship with them. And as I mentioned, I started off as a software engineer. So I started off in the world of games. But being that I like to try out different things and learn more stuff, I ended up joining the data and decision sciences team, which led to my current employment there. So, my piece of advice would definitely be to try things that you don't think you'll like, try things that are different, try things that might scare you because you're going to be surprised by where you end up by doing those things.
Thank you. And then for those that don't know about war games, you may not realize Emily's heard this like 20 times because I stumbled on this. In 2006, Rand Corporation, working for the government, produced a quote unquote war game, which is also known as a tabletop exercise to plan for a future pandemic similar to a flu and how it might affect local communities and the overall government, and figured out how to game out the whole thing. Yes, it was actually COVID in 2006. All figured out. You decide whether or not we followed the tabletop. Games can save lives. Just put that out there.
Yep, games are a lot more than just fun. I mean, I'm not sure if you guys are familiar, but there's a whole genre of serious games out there. And if you're interested in this kind of work, I would start looking into those. Does anyone have any questions about the GIS side of things? I know I sort of went through that really fast. There's a lot of information. It's a pretty intricate process, but like I mentioned, I wanted to have it all out there on slides with links and stuff so you guys can go back anytime when you're starting to work on these final projects or just dabbling around on your own. But yeah, do you guys have any questions about anything that I presented today?
I got a question.
Mhm.
Just so like when you made the game, like those attributes on the side, was that made in Unity or was that using like attributes from ArcGIS?
Sure, yeah, good question. So, just to make things easier, that was done in Unity, but it can easily be done in ArcGIS too. So, if you've made a couple different fields that have those values in ArcGIS, what you can do is when you pull in the map layer from ArcGIS Online to Unity, you can extract that data and you can store it in either an array or a list or however what you want to store it. And then that's something that you can visualize in Unity, but just for the sake of time, they're all randomized values that I just put in from Unity.
Okay. All right. Yeah. Thank you.
Yep. I see a question in the chat. For the layer that you used in Unity, is it different than a normal feature layer? Um, yes and no. So I'm trying to think of a good way to explain this. So I'm not sure if you guys remember, but couple slides back, we had this layer. This is what a normal feature layer looks like when you just import it into Unity from ArcGIS Online. I didn't really care much about how the visualization looked because what I ended up doing is to put down my own game objects in place of it. I sort of made this map layer transparent and I used the coordinates for each tile, which I guess I don't have the tiles on this one, but I use the coordinates for each tile to use the geolocation tool that's part of the Maps SDK and to place game objects accordingly. So that map layer is actually still there. It's just transparent, so you can't see it. Does that kind of answer the question? Cool. Does anybody else have any other questions? Apparently, there's only 6 minutes left of the meeting. I forgot that since I'm still an RIT student using Zoom, I'm limited by time. So speak now if you have any questions. All right. Well, thank you everyone for listening to my presentation. I'm sorry if I hurt your brains at 8 o'clock in the morning. It's way too early to have this much knowledge ingested. But yeah, I hope that you found this at least somewhat helpful and it gives you a better idea of how cool it is to add GIS into games. And I hope that you can use this recording and the slides that I'm going to send you afterwards as a good reference for some of the work later down the line. So, yep.
Thanks, Emily.
Yeah, no problem. Thank you guys.
Thank you.
Hi, this is Brian Tomaszewski. If you enjoyed this video, be sure to like, comment, and share this video. Also, please consider subscribing to this channel and clicking the notification icon to stay up to date on new videos from this channel. Thanks for watching.